Hey folks, let's talk about matrix notation and some terms as a part of the continuation to our matrices and determinants crash course. So let's jump into this episode where we'll be talking about few interesting terms and terminologies. Okay, so we all know that the origin of matrix has to do with a solving system of linear equations, which is what we see here and which is what see here, and eventually this just become one of the applications, but this is where the origin was in solving. And in elementary school, we know that how we solve this equation. To find x, we make y is equal to 0. And then to find y, we find x by making y is equal to 0. And then we find y by making x is equal to 0. And then put back the values to just check whether the answers match or not. And this works great in terms of two equations and two unknowns, which is what the 2 by 2 matrix is all about over here. And which is still we can do it, but it's slightly lengthy to in higher order where we have got 3 rows and 3 columns, or the order is 3 by 3. But that's what it means when you say solving system of linear equations. Equations of this type, where the x and y variables are expressed in terms of the constant, means that we need to find the value of x and y, which is what solving system of linear equations mean. And a lot of matrices and determinants revolve around these problems. And similarly over here, since this is a 3-dimension or it's an xyz plane, which is what we can imagine this way, and there's 2 dimensions. We have the z variable, that the concept is same. When we say solve or find the solution of this, where we have been given the values of x, y, and z in terms of constants on the right side, our job is to find the values of x, y, and z. That's what kind of a quick recap on the system of linear equations. And like I said, the number of equations and the number of unknowns should be matching, otherwise you will not be able to solve. Over here you have got 2 unknowns, x and y, and you've got 2 equations. This is 1 and this is 2. Over here you've got 3 unknowns, x, y, and z, and you have got 3 equations. So as long as that matches, you can solve this equation. Now, when we condense this into a matrix format, how do we represent and what are some of the terms that are used? So in matrix format, when you feed these numbers to solve this matrix for x and y, either to a computer or a calculator, for a variety of reasons, computer graphics, cryptography, whatever it is, what the computer does is a computer just worries about the abstract and it just needs the notation on what it is. So what we're trying to do is we're abstracting, meaning we are extracting just the numbers and with the algebraic signs and expressing them in this compact format, which is called as a matrix equation, which is what we see here. For example, ax is equal to b. And again, if you see, all of them are in capital. That's what matrices mean. It's all in capital and box brackets. So what it means is we're going to take this equation or this equation and express them in matrix format, which is equal to B, where all the 3 are matrices. And what do they mean? The first matrix on the left, it's just the coefficient of the main matrix on the left-hand side of the equal sign, or on the right-hand side if this is kind of the other side. So wherever we have coefficients assigned, numbers assigned to x and y, whatever that matrix is, that is called as coefficient matrix. If you see, these are coefficients of x and y. The first column represents x, all of x, 5 and 1. The second column represents all of the y values. That's how it is, along with the algebraic sign. So if you see 5 and minus 4, that's the A part. The second matrix A, x, is kind of the unknown. Although it says x, we are going to find the unknowns xy or xyz. That is going to be the next matrix, which is what represented here. So whatever are the variables that are number of unknowns, in this case 2, and in this case 3, over here if you see unknowns, you put that as a variable matrix or the x matrix, doesn't matter what you call, but these names are more standard. Followed coefficient matrix and then the variable matrix, and whatever is on the other side of the equal sign, which is a constant, that's called as a constant matrix, because x and y are expressed in terms of constant. So whatever is on the other side of the equal sign, which is a constant number, are packaged into a matrix format, and the computer or the calculator just cares about this notation and it will give the answer on what is x and what is y. Similarly over here, we have kind of extracted all the coefficients of x, y, z along with the algebraic sign over here. And the first column is all x. If you see this way, it's aligned, y and z. The second matrix, although it's not multiplied, but you can think about ax is equal to b in that format because it's a multiplication. And once you see matrix multiplication and once you do the operation on this, we'll go back to this. That's how you'll see. So x is the variable matrix, x, y, z, and this is the constant matrix. So that's what matrix notation is all about, and there are some terms and terminologies. And before we go to the next byte, this is the nomenclature that you should understand. What is the notation? because in the exam you might be just given the notation and you should know what's happening. Mainly the letters are in capital, which represent matrices, and the boxes are square, which represent matrices. I'll see you in the next byte, folks. Thank you.